Okay, back again in section 10.1, still dealing with proportions. I took number 14 and 16 and kind of put the two together into one problem. So here's our context. Steroids in high school. A study by the National Athletic Trainers Association surveyed random samples of 1,679 high school freshmen and 1,366 high school seniors in Illinois. Results showed that 34 of the freshmen and 24 of the seniors had used anabolic steroids. Steroids, which are dangerous, are sometimes used in an attempt to improve athletic performance. Just a little thrown off. I think it's kind of funny that they pointed out that they're dangerous. Hopefully you all know that steroids are in fact dangerous, and we've made that clear here. So continuing with our problem, Do the data give convincing evidence of a difference in the proportion of all Illinois high school freshmen and seniors who have used anabolic steroids at the alpha equal 0.05 level? So in order to do that, because we're doing a test of significance, and first just to point out, as soon as you read this, do the data give convincing evidence, right there that should tell you that you're using a test of significance rather than a confidence interval. And for a test of significance, we always have to start by stating our null and alternative hypotheses. So I made my null hypothesis P1 equal to P2, and my alternative P1 is not equal to P2. Now I know this is a little different than what you're seeing in your book. In the book, a lot of times it'll say P1 minus P2 is equal to 0, and then P1 minus P2 is not equal to 0. The reason I choose to write it this way instead is because this is what it's going to look like in your calculator. When you go to your calculator, it's going to ask you for what your what your alternative hypothesis is, and it's going to look like this. It's either going to say not equal to P2 or greater than P2 or less than P2. So to make it better align with the calculator, I write it this way. It is fine to write it the other way, P1 minus P2 is equal to 0. You're just going to have to make sure when you're using your calculator that you keep track of what it means in terms of what the calculator is going to say. So when you write your hypotheses, you also should define your parameter of interest. In this case, we have the true proportion of Illinois high school freshmen who have used anabolic steroids, and then the same thing for the seniors. And again, you should also define what your alpha level is. We put all this stuff right here in the beginning because when we go to write our conclusion, we'll just be coming back to this part of it. Now that we know what our hypotheses are, we're going to state our test. We would be doing a two-proportion z-test. The reason I think it's a good idea to state these right from the beginning is it also sets the tone for what conditions need to be checked and what formulas need to be used. So moving on to the conditions to check, they're the same as the conditions in the last problem, and really they're the same as the conditions from the last two chapters. We have independent random samples, both of which should be less than 10% of their populations. And the n times p and n times 1 minus p conditions, I just wrote here n times p is 34, n times 1 minus p is 1645. Then we have 24 and 1342. Both of those are clearly greater than 10. So we can proceed with our procedures. We can keep going with our procedures. I'm going to use technology again. With your two samples, technology is so much easier to use than trying to go through with the formula. The formulas become much more complicated as we move through the rest of the book. So I really encourage you to learn how to use your technology on this stuff. So technology, when you go to it, again, you're looking for what you've named your test, which was a 2-prop z test. So that's what I'm going to look for in my calculator. Then I'm going to input what they asked for. X1 is 34, N1 is 1679, X2 is 24, N2 is 1366. And again, like I said, the calculator is going to ask you for what your alternative hypothesis is. And it's going to look, really what you're going to see is there'll be P1, and then next to it it'll say not equal to P2, and then there's a greater than or a less than P2. So again, we're just trying to have our hypotheses align with the way that the calculator is going to ask for it. After you hit calculate, you're going to get out that your z is equal to 0.5382 and that your p is equal to 0.5904. Right away from that z value of 0.53 only being half a standard deviation away, that should tell you that there's a really good probability of this occurring. So we shouldn't be surprised by that 0.59. Although it's really large compared to what we usually deal with, it makes sense with our z score that we got. Okay, so based on that, we will write our conclusion. So our conclusion would be, since 0.5904 is greater than 0.05, we would fail to reject. Now we're going to give that in the context of the problem, which would say there is not statistically significant evidence. Now when I write this, I always look back at what the problem is. So I'm going to scroll to where the problem is. It asks, do the data give convincing evidence of a difference in the proportion of all Illinois high school freshmen and seniors who have used anabolic steroids? So as soon as I just got done writing there is not statistically significant evidence, I'm going to come up here, take that word evidence, and keep writing from there. You don't have to be doing creative writing here. Just use what was already given to you. So if I use what was given to me, there's not statistically significant evidence of a difference in the proportion of all Illinois high school freshmen and seniors who have used anabolic steroids. All right, that'll do it for section 10.1. I'll see you again in section 10.2.